Hey there, this is Peter with Valley CAD, and welcome to another Take a Break with Valley CAD. In today's video, we're going to see how much force we can put onto a part file. We're going to be playing with SOLIDWORKS Simulation. So go get your favorite cup of coffee or your favorite cup of tea, and let's go take another break with Valley CAD. Hey there, welcome to SOLIDWORKS. So we're going to take this simple part file here and we're going to apply 500 newtons onto this counterbore that's living right here. And then we're going to make this part fixed based off of these two holes here. Okay, so SOLIDWORKS Simulation. This is available if you have SOLIDWORKS Premium or you have the full simulation suite from SOLIDWORKS. There's Simulation Standard, Simulation Pro, and Simulation Premium. This is on top of the SOLIDWORKS core products, okay? So simulation, this is an awesome tool to be able to come in and verify, hey, is this part gonna work? Okay, so where do we come in and turn on simulation? And by the way, you have to have, like I said earlier, you have to have SOLIDWORKS Premium or the simulation products. So if you do have those items, where do you turn this on? Well, one way you could do it is you simply see a tab here that says SOLIDWORKS add-ins. You can simply click on that. And if you have SOLIDWORKS Premium or higher, you'll see that you have a SOLIDWORKS simulation function there. You simply click on that and that will start up that add-in for you. The other way you could simply go about it is you come up to the top dead center of your screen and you'll see a sprocket there. Move your cursor just to the right, click on this drop down and you'll see add-ins. From the add-ins is where you can come in and turn on your add-ins for SOLIDWORKS. So in this scenario, we want SOLIDWORKS Simulation, which is currently turned on. If you want to make it so that simulation starts up every single time you start up SOLIDWORKS, you would come over to this column on the right and you would check box here. Now keep in mind, as you make add-ins turn on when you start up SOLIDWORKS, it will take a longer time for SOLIDWORKS to load up. Okay, so that's just a little catch there with that. So anyways, we'll just simply say okay to that. So now we have simulation turned on. Let's run our first static test. So we'll simply come under the simulation tab. And with that simulation tab on, we can simply see here and see a new study. Simply click on that. SOLIDWORKS is going to come in, and because this is a simple part, you'll see it's just going to ask for a simple static study for me. And we can name this whatever we want. So I'm just going to call it static one in this scenario. Now that we did that, SOLIDWORKS is going to come in and it's going to have a new set of icons that are located underneath your design tree. So simply from here, what we're going to do is apply a material. Okay, so how do you apply a material in a simulation? Well, you simply see up here underneath static one, it has a little kind of like a cube, like a deformed cube. You simply right click on that and you can see here, you can say apply favorite material or apply edit material. Now this is really cool. You can actually have multiple simulation studies in a single file and you can apply different materials on each of those studies. I really love that function with SOLIDWORKS Simulation. So we're going to come in and say apply and edit material. As we do this, it's going to be this typical box that you're familiar with, the window that comes up, just like when you apply material to a simple part file. What we want to do is come in here and we want to apply what's called a 1060 alloy. So I'm going to come under aluminum alloys and I'm going to select 1060 alloy. You'll notice here that in my properties here, I have different colored text. I have red and blue. Whenever you have red text, that is necessary for you to run an accurate simulation on there. The blue ones are kind of like cherries on top. Like it's not a necessity, but hey, it's a good thing to have and it will be utilized for your simulation. So keep in mind, if you are coming in and making your own materials, make sure you are coming in and at least putting in your yield strength, mass density, elastic modules, and also your poisons ratio. Okay, so with the 1060 alloy selected, I'm just going to simply say apply. You'll see that my part has changed color just slightly. And you know what, just have fun with it. We'll make it so that we're real graphics to you as well, just to make it a little prettier, right? Now the next step, what we're going to do is we want to apply fixtures. Now we don't need to do this in order where it has to be fixtures, then apply force, or the other way around. Doesn't have to be that way. It's not like in your normal design tree where you have to do things in a certain order or procedure. You don't need to worry about that. But I like to come down from the top down and apply the parameters to whatever my study is as I see it. So we're gonna skip the connections. Connections is used when you have a multi-body part design or assembly. Since we don't have that, we're not gonna worry about that here, but we're gonna come under fixtures. Now, what's really cool is that you could come in under here and right click and apply your fixture here, or you could simply come up to the top of your screen, and under the simulation tab, there's also a fixture unit. To let you know, whenever you see the term advisor after the command, that will actually open up an advisor that's on the right side of your screen on your task pane side, and it kind of acts like a wizard, like it helps you move along the process and making sure that you're doing everything in order. Okay, but anyways, we'll just simply click on the drop down and we'll say that we want to do a fixed geometry. From here, SOLIDWORKS is going to ask you, hey, what's the items that are not supposed to move? Well, in this scenario, I said that I wanted this hole and this hole to not move. Those are the items that are being locked down and fixed. Now I'll simply say okay again. Then from there, what I want to do is apply an external load. So just like with fixtures, you can come up here to top and click on an item, or you can simply right click on the item and you can say, I want to apply a force. So we'll simply say apply a force here. As we set up our force parameters, it's going to ask us to select a face. So I said that the counterbore is our moving face. That's where the force is being applied. And I'm going to up this from 1 Newton to 500 Newtons. And we'll simply say okay to this. Now with our 500 Newtons set up on a force, the next thing that we're going to need to look at is updating our mesh. Now meshing is coming in and it's breaking up each of the faces that you have on your file or your body, whatever terminology you want to use here. And what it'll do is it'll create elements for you. And so let me load up the mesh parameter, and while that's loading up, I'll still keep talking here. So as it's loading up our mesh properties here, you'll see that we have a slider bar. We have a coarse and we have a fine. So if you have it on coarse, what that's going to do is going to make a smaller number of elements. And by the way, where those elements all connect, they actually look like triangles. Where they connect, that will end up making what's called a node. So the coarser you make it, the less amount of elements you have and the less amount of nodes you have. That will make it to where your results won't be as accurate, but it will take a shorter amount of time for it to actually run through the study. On the flip side, if I switch this over to fine, it will add more elements and also more nodes, which will then give me a more accurate result. But because I am adding so many facets to this thing, it's going to take a longer time for it to analyze it. So in this scenario, I'm just going to simply say go to reset to make it so it goes back towards the center. And we'll simply click the green check mark there. As it's doing that, you'll now see that SOLIDWORKS came in and it made all these little triangles on my part file here. These are all your facets. And like I said, where all those triangles connect, those are now called nodes. So since we just kept it kind of 50%, it's a pretty good average here. Now that we applied our force, we applied our fixture, and we also updated our mesh on this unit, we can actually come in and run this study. So as we come up to the top here, it says run this study, simply click on that. SOLIDWORKS is going to come in here and it's going to now create your file. And it's going to come up with some results for you. Your results are going to say stress 1, displacement 1, and strain 1. So as we look at our stress setup here, you'll see that I got a model that's being shifted way over towards the right. And you'll see that we got items that are blue, we got areas that are green and yellow, and we also have units that are red, or entities that are red. To let you know, with the von Mises stress analysis here, what it's saying is that everything that is above this arrow, like in this reddish area, that's going to be a deformed unit and it will not go back to its original state, meaning it broke. Okay, so we see some areas that are red and that's not good, and there's an area in here that's got some reddish color to it a little bit, but that first hole there is really bad. The other thing that we can also do is see our displacement. Just simply double click on it and this will show the amount of movement that's moving on this guy. Now it's also really fun about simulation is you can make your part dance. You simply right click on something and you can say animate. You'll see that SOLIDWORKS coming in here and it's making my part dance. And I can also make it so that it's, it's a little bit faster or slower. So you see how it's saying 150. If we slow this down to like 10, you'll see that it's just barely moving. And what's really fun is that I can move my model around and see different variables on this guy. Now, with this movement setup, that is pretty extreme looking, right? It's like, that's a massive amount of movement. Well, that movement is actually being multiplied by a deformation scale of 231. So whatever the actual movement is, it's actually being multiplied by 231. So that's why it kind of looks extreme. It's really not moving that bad, okay? But as we looked at this simulation here, we saw that, hey, this part's actually gonna break if we have 500 newtons being pushed along here, and it's really gonna break around this hole actually. So being able to come in and visually see that, it will now allow us to come in and test out different materials, or maybe we need to make the part thicker, or whatever variables we need to change on there. So this is just an entry level of looking at simulation with SOLIDWORKS. I hope this was a useful video for you as you were able to chug your coffee or tea during your break. Come back next time for another Take a Break with Valley CAD. Have a great rest of the day and make sure you learn something new.